What if I told you dinosaurs weren't all giant scaly beasts, but some were small, fluffy, and even colorful? What if the bird we see today, sparrows, crows, even chickens, are actually living dinosaurs? For years, we pictured dinosaurs as cold, gray monsters. But fossil discoveries have changed everything. Some had feathers, wings, and even the power to glide. From tiny, fuzzy hunters to giant, shaggy predators, these creatures blur the line between dinosaur and bird. In this journey, we'll meet 10 incredible dinosaurs that prove the age of dinosaurs never really ended. It just took flight. Archaeopteryx was once hailed as the first true bird, even though it still had features we link to classic dinosaurs. It lived around 150 million years ago in an area that is now southern Germany, and its remarkable fossils were found in limestone that preserved delicate details, including impressions of flight feathers. It was only about the size of a crow, but it had a long bony tail, little teeth in its jaws, and claws on its wings, so it clearly wasn't a modern bird. Still, it had real wings with asymmetrical feathers that allowed it to glide or maybe perform clumsy flights among Jurassic trees. The discovery of this creature in the 19th century provided early support for the idea that birds had evolved from dinosaurs, and it thrilled scientists like Charles Darwin, who saw it as a missing link. Fossil hunters have since found multiple specimens, each showing that Archaeopteryx had plumage much like a bird, including strong wing feathers and a tail fan. The idea that something from the dinosaur era could look so bird-like was shocking at the time. Even today, Archaeopteryx reminds us that evolution is often a game of small steps, where feathers meant for warmth or display might eventually be used for flight. Sinosauropteryx was a cat-sized hunter that lived about 124 to 122 million years ago in what is now northeastern China. When its fossils were first studied in the late 1990s, paleontologists were astonished to see a halo of fuzzy filaments along its neck and back. The earliest clear evidence of feathers on a dinosaur that was not a direct ancestor of modern birds. These were simple, hair-like structures rather than the complex flight feathers of birds, yet they still played a role in insulation and perhaps in attracting mates or intimidating rivals. Even more amazing, scientists realized that its tail had alternating light and dark bands, which might have been a ginger color and white or pale shading. Imagine a ring-tailed little dinosaur zipping around the underbrush, warm and protected by a fluffy coat. This find ended the idea that all dinosaurs were strictly scaly, proving that feathers went beyond the lineage leading to birds and spread more widely among certain groups of predatory dinosaurs. Caudipteryx was a small, turkey-sized dinosaur that walked the same early Cretaceous landscapes of Liaoning, China, around 125 million years ago. It belongs to the Oviraptorosaur group, known for beaked mouths and, in some species, crests or head ornaments. What made Caudipteryx stand out were the big, fan-like feathers on its short arms and tail, which looked strikingly like those of modern birds, long, vein-like plumes with a central shaft. Yet these feathers were symmetrical and not ideal for flight, and its arms were too tiny to act as wings. This was a huge clue that feathers probably did not appear only for flight. They must have also been important for display or temperature regulation. Caudipteryx even had stone-like bits in its stomach, called gastroliths, which modern birds used to grind their food. This dinosaur's discovery made a giant impact on the debate about bird origins, since it blended typical dinosaur traits with obvious feathers, all on an animal that had no chance of taking to the skies. Microraptor was like a living glider experiment. It had 4 limbs covered with proper flight feathers, so it was basically a dinosaur with wings on its arms and legs, plus a fan of feathers on its tail. This crow-sized predator lived about 120 million years ago in China's forests, where it may have launched itself from tree branches to glide like a flying squirrel, possibly making short flaps to extend its travel. Fossils reveal that its feathers were not simple fuzz but showed advanced flight structures that even included asymmetry, something we see in modern birds' flight feathers. One of the most eye-catching details about Microraptor is that its feathers were probably glossy black and iridescent, meaning they had a shiny, color-shifting gleam like a raven or starling. Not only does this suggest that feathers evolved for more than flight, perhaps for show, it also means Microraptor might be the earliest known creature with shimmering coloration. That means if you were lucky enough to see one in real life, you'd witness a black, 4-winged, dragonfly-like dinosaur gliding overhead, glowing in the sunlight. Velociraptor is famous from movies, but the real animal was quite different, standing perhaps half a meter tall at the hip and weighing around 15 kilograms. It lived about 75 million years ago in Mongolia's deserts, where it likely hunted small prey or scavenged on carcasses. Back in 2007, Paleontologists announced the discovery of quill knobs on a velociraptor's arm bones. These are the bumps where strong feathers anchor to the bone, proving that even this swift predator was feathered. Although it had feathers, it was definitely not a flyer. Its body was built for running on two legs with a stiff, balancing tail. But feathers could have served various roles, from display to shielding eggs from the sun or cold. Velociraptor belonged to the family of dromaeosaurs, which were close cousins to the ancestors of birds, and they shared a flexible wrist and other bird-like features. The movie version of Velociraptor was scaled up in size and missing feathers, but in reality, it was more like an aggressive, feathered turkey running across the sand, darting after its next meal. Yutyrannus is one of the biggest surprises in dinosaur paleontology because it showed that even large tyrannosaurs could be covered in feathers. This giant lived about 125 million years ago in what is now northeastern China and reached around 9 meters in length, weighing more than a ton. Its fossils clearly display large patches of filament-like feathers, up to nearly 20 centimeters long, on different parts of its body. These feathery filaments likely served as insulation in cooler climates or perhaps played a role in display. It's fascinating to imagine a predator the length of a bus, sporting a shaggy, hair-like plumage all over its back and sides. Although T. rex itself is often shown as scaly, Yutyrannus proves that big-bodied meat-eaters in that family were perfectly capable of growing feathers. Some experts suggest that since T. rex lived later and in hotter environments, it might have lost most of its fuzzy coat as an adult. In any case, Yutyrannus smashes the stereotype that feathers were only for small dinosaurs or solely for creatures heading toward birdhood. Archaeopteryx, whose name means near bird, glided through the late Jurassic forest of China about 160 million years ago. It was around the size of a pigeon, but it carried an exciting arrangement of feathers, including plenty of long flight feathers on both arms and legs, giving it 4 winged surfaces. Specialists have studied Archaeopteryx fossils so precisely that they even worked out its color palette. It seems to have had mostly black and gray feathers with white striping on its wings and a striking patch of reddish-orange feathers on its head, much like certain modern birds with vivid crests. Archaeopteryx possibly used these bright colors to signal mates or rivals, and it might have glided among tree branches, though whether it could manage true powered flight is still debated. Since it appeared at least 10 million years before Archaeopteryx, Archaeopteryx helps us realize that feathers and wing-like arms popped up in dinosaur evolution earlier than once suspected, proving again that the border between bird and dinosaur was blurry. Oviraptor and its close relative Pseudopodi were strange, beaked dinosaurs from the late Cretaceous, around 75 million years ago, living in Mongolia's Gobi Desert. Early discoveries led some paleontologists to think these animals stole and ate eggs, hence the name Oviraptor, meaning egg thief. But later finds showed individuals in a perfect brooding posture, perched on top of a nest of eggs with arms spread out as though they were sitting on them. This scene is identical to how modern birds protect their clutches. While direct impressions of Oviraptor's feathers are rare, enough skeletons from related species, such as Caudipteryx, indicate they had full plumage, possibly including tail fans and wing feathers used for egg warming and display. We now believe those eggs found with Oviraptor were its own, proving it was more like a caring parent than a nest raider. These toothless, parrot-like creatures must have looked quite showy, standing guard over their nests as the desert sun blazed overhead. Deinonychus roamed parts of North America around 115 million years ago, and it became famous for sparking the dinosaur renaissance in the late 20th century. When paleontologist John Ostrom studied its skeleton, he noticed many traits in common with Archaeopteryx, including wrist bones that allowed flexible, bird-like movement. Although actual feather impressions haven't been found with Deinonychus, experts are confident it had them because it's part of the same dromaeosaur family as feathered fossils like Velociraptor and Microraptor. Deinonychus was bigger than Velociraptor, perhaps up to 3 meters long, with a curved sickle claw on each foot, used to grab onto prey. Its discovery changed our understanding of dinosaurs, suggesting they were not the slow, cold-blooded reptiles of old paintings but agile, smart, warm-blooded hunters. Even though popular culture often calls the human-sized predators in films velociraptors, they're really much closer to Deinonychus, only missing the feathers that science now recognizes as common to this group. Bipiosaurus adds yet another twist to the story because it was a plant-eating dinosaur with feathers, showing that plumage wasn't just for meat-eaters or for flying. It lived around 125 million years ago in what's now China and belonged to the odd Therizinosaur family, which had potbellies, long arms, and huge claws perfect for pulling down branches. Fossils showed that Bipiosaurus wore a coat of different kinds of feathers, including simple filaments for insulation and longer, strange, ribbon-like feathers. These unusual plumes might have served as flashy displays to impress potential mates or rival herbivores. At about 2 meters long, Bipiosaurus would have looked quite unusual with its thick body, long neck, and huge claws, all draped in a shaggy brown covering. It was the largest known feathered dinosaur for a while, until the discovery of Yutyrannus. Together, these discoveries remind us that feathers are not just about flight. They can serve many functions, from keeping warm to courting attention, whether on a fierce predator or on a gentle giant munching on vegetation. This variety drives home the point that birds are living dinosaurs, and the colorful, feathery world we see today had its roots millions of years ago, long before any humans set foot on Earth.